Alright, here we are back at part 2. Everything on the board is the same. Let me see if I can straighten that a wee bit. A little bit crooked. Not too bad. Alright, we'll go with that. Alright. It says sine of 2x equals negative square root of 3 over 2. And on the unit circle, we find that that is negative, the sign is negative over here at 4 pi over 3. And also, we find a negative square root of 3 over 2 as our second coordinate as 5 at 5 pi over 3. So notice the difference between this and the other problems that we usually had an x here, but now we take this whole thing, 2x equals this. Alright, so that is true, but in the end of our story, we don't want to know what 2x equals, we want to know what x equals. So we're going to address that. Are there any more spots, now that we have enlarged this place where we can look for answers, where where the sine of 2x equals negative square root of 3 over 2? There are. So, because we have increased this, can we not go around one more time? Here's 4 pi. 4 pi over 3 is down here in the somewhere about right there. So let's see if we can, here was 4 pi over 3. Let's see if we can spin it once. So when I spin it, I'm actually adding 2 pi to it. So what's 4/3 pi plus, and I can change this 2 pi in my mind to 6/3 pi. 4/3 plus 6/3 is 10/3 pi. Is that in our range? Is that, the 10/3 is about 3 1/3, so yes, we have not got to 4 pi yet. What about, can we spin this one? This one resides in the 4th quadrant, about here. And if I spin, what I call spin, I'm looking for a larger coterminal angle. So when I go around and around, I'm adding another circle, 2 pi to this one. So when I do that, 5/3 plus 6/3 is 5 and 6, 11/3 pi. So, is 11/3 still in range? Is it gone out? 11/3 is 3, is a little more, 3 2/3. So, it is still not out of range. So, let me get rid of this clutter. We've got 4 answers, and now I'm going to, I already spun this one, I added 2 pi to that, I already spun this one. Should I spin this one? So this one was already pictured here. Can I spin it again and go around again? Can I add 2 pi to this? 10/3 plus 6/3 is 16/3. Do you see how 16/3 pi is we went out of the range? Because 4 pi is there's 3/3 in each, so that's 12/3 pi. So we went out of range by spinning this one. So we don't need any more than that. So here's our 4 answers. Let me gather them on one row. 2x equals 4, 5, 10, and 11/3 pi. 2x equals 4/3 pi, 5/3 pi, what was this one? 10/3 pi, and 11/3 pi. Excuse me, 0. I'll move all this. So this was my 2x here. And 11/3 pi. Alright. So we came up with these without splitting up the 2x, which resided after the sign. But once I've taken the sign and found these spots, I now can split it up. So I don't want to know what 2x equals, I want to know what x equals. So I divide this by 2, this by 2. this by 2, this by 2, and this by 2. Dividing that by 2 just alters the denominators, because this becomes 4 pi over 6. This becomes 5 pi over 6. This becomes 10 pi over 6. And this becomes 11 pi over 6. Alright, let me see. This one can be reduced. So I'll change 4/6 to 2/3. Is there any other reductions? 5/6 can be 5/3. Alright, so let me look at the answer here and see how we did. We did wunderbar. Wunderbar. Okay, here we are. So, there is how we handle it when the angles are multiple angles. What if this was a 3, you say? I hear you from across the miles. If this was a 3, this would be multiplied by 3, and this would be multiplied by 3. So we'd be looking between 0 and 6 pi. Then, when we did our spinning, we would find many more answers. Not many. You'll find as a general rule, but not always, that when the angle is double, you'll find 4 answers. When the angle is tripled, you'll find 6 answers. When it is quadrupled, you'll find 8 answers. That's just a general rule. It's not always the case. All right. I think I said I was going to do 2 of these problems, but I think this will form a foundation that we can do any of them. So I think this is strong enough to get us through the rest of our blue paper. We'll be working on these kind tomorrow, so till then, Shazam!